Everyone, we're going to give this a shot here. Let me get this started. Lord, wonder what's gonna matter. Yeah, with time, you know with time. Hours pass so slowly, heavy burden with a chain, but I hold up my hand. I'm trying to make everybody understand. Somebody went and told me, yeah, they done hoodoo the hoodoo man. Buzz the bell come up this morning, elevators running slow. Buzz the bell trying to get up there, oh, to the third floor. When I hold up mine, I'm trying to make my baby understand. Yeah, she went and told me somebody hoodoo, the hoodoo man. All right, blues in G, harp blues in G. What I'm going to do, we're going to have our math lesson. This is Mr. Pat from the Windward Boys and Girls Club. We're going to have our math lesson today. I wanted to blow the harp again and tell you it's in the key of G. That probably didn't mean a lot to you unless you're a musician and already doing that kind of thing. But I'm going to teach you tomorrow and the next day a little bit, remind you of the 1-4-5 stuff we talked about way long ago, and how you use that if you're choosing a harmonica to play to a song. Because some of you might look at this and learn. Just make it really simple, and how to choose the right one, because you need to buy different harmonicas. It's very hard to play one particular harmonica across the board to every song and every key. So it's just another bit of information, music hack stuff thrown into the algebra. Okay, I'm going to shift this board and we're going to talk about some real math here. So we're going to keep building on what we did last week, and that's going to be the remainder of this lesson today. So what's going to happen is, you can see by the title, this talks about something called the quadratic function. So we're still graphing those parabolas, those orange things over there. So you can see from this what we're doing, we're going to still be using the same thing. You're going to still use that formula. You're going to find the A, B, C values, and you're going to use that negative B over 2A, and you're going to find all this stuff. The parabola is the orange U, that dotted line going down the middle. I make it dotted to tell it apart from the axis. That's the axis of symmetry. It's balanced around that axis. Okay, the vertex in this case is the bottommost point. If the U was flipped upside down, it would be the top. You heard me say all this. The y-intercept's where it crosses the y-axis, and we learn whatever this is. There's another point over here that matches it. And then last time we used factoring, and we found these x-intercepts. And we're going to keep doing all that stuff. But what we're going to do today is learn this new formula that is the very complicated version of that type of thing. And it's going to let us find these 2 points when we can't factor. So you still got to do all the other stuff, but you use the quadratic function to find the x-intercepts where it crosses the x-axis when you're unable to factor. Okay, and that's what today's lesson is. We're not gonna actually graph today. So I'm gonna erase all this. Today we're gonna use this tripped out formula and a couple examples just to show you how to work with it to do that. Then tomorrow we'll put the whole package together. All right, I need room to work here. This is a fairly insane formula looking. Students first see this, they freak out. Okay, quadratic function. Just realized I wrote function up there. I am so sorry. That is just hilarious. We are learning how to use the quadratic formula. So instead of negative b over 2a, we got this going. It graphs quadratic functions. So I think you'll let me live with that. Okay, so now the title is correct. Sorry about that. All right, so your formula is going to kind of blow your mind. It starts with x equals, and then it's very complicated looking. It's negative b plus or minus this big square root inside here is 4ac. Sorry, x squared minus 4ac. Getting ahead of myself here. Okay, so negative b plus or minus the square root of b squared. Boy, I'm butchering that. Okay. Normally I'd redo it, but I like you to see how my mind's racing ahead, so I'm writing some weird things down, but I'm checking myself the whole way I go. And as a teacher, I believe in that. I like you to see how we're not perfect, just like you guys aren't, but I always check myself. Now I got it correct. It's b squared minus 4ac. The formula is exactly like you'd want it to look, and we're going to put that to use. So you got to see Mr. Pat and all his wrinkles and everything. You finally got it ironed out. Okay, here we go. Example number 1. Okay, 3x squared plus 5x minus 8 equals 0. So you still need to do the ABC and all that, but you need, as always, to make sure you get everything on one side. So you have to use this formula, and you have to use it once everything's isolated on the left or right side. Most students like it on the left like this, but the other way works just as good. But if one of these was over there, you'd have to move it over first. So your first move is always going to be same basic thing. So you're going to put A equals, B equals, and C equals. And you're going to be very careful with that. A is the number multiplying times the quadratic, the x squared, positive 3. B is the 1 times the x, the linear term, that's a positive 5. And C is the constant, that's negative 8. Okay, double check yourself. All right, now we're going to put those numbers into that formula. Ready for that? So what I'll do is I will, A, B, and C. So x equals negative b. So b is positive 5, so there's negative 5 plus or minus the square root of, b squared. So I put a b here for b squared minus, got to be really careful here, 4 times a times c. Okay, so there's negative from the formula b. B squared, 4a is 3, c is that. And that whole thing goes over 2 times 3. Right? Okay. Okay, so x equals negative 5, that's what that is, plus or minus 25, that's what b squared is, make sure you don't put 10 there. Okay, now check this out. 4 times 3 is 12. 12 times 8 is 96. But it's negative. So you got this minus right here, okay, is right there. Then 12 times negative 8 is negative 96. Because you got positive 12 times negative 8, and I wrote that there. Okay, don't forget the 2a. A lot of students get involved in this and forget 2 times 3 is 6. Okay, so I'm going to just put equals and work over here. So negative 5 plus or minus the square root. Okay, now go back over here for a second. Remember when your teachers taught you subtraction and they went leave, change, opposite. So subtracting negative 96 is like adding positive 96. So I add those together, and 25 and 96 is 121. So I end up over here with 25 plus 121. Oh, sorry, what am I doing? That's just 121. My bad, because I combined those two. Okay, don't forget your 6. Now that in itself looks a little whack. Okay, so here's what we do. Square root of 121 is 11. So x equals negative 5 plus or minus, okay, the square root of 121 is 11. So negative 5 plus or minus, instead of square root of 121, I'm going to write 11 over 6. And what that does, it means this goes into 2 separate problems because of this. So what that does is x equals negative 5 plus 11 over 6, and x equals negative 5 minus 11 over 6. So that's what that means. So negative 5 plus 11 is 6. So in one case, you get x is 6 over 6, which equals 1. That's one of your answers. That is an x-intercept. This is a little more challenging. You get negative 16 over 6. Okay. So x equals, so 6 goes into 16 twice with 4 left over, so it's 2 and 4/6 or 2 and 2/3. So this is negative 2 and 2/3. So ladies and gentlemen, these are the two places that graph would cross the x-axis. These are the x-intercepts of that. So you can see this is nuts. This is crazy. You can also see I'm a math teacher and I still, get all spun around, but I check myself every step of the way. I go slow. It's good for you to see mistakes as they occur because it happens to all of us. The key is that you go slow, you check your steps, and then you won't waste your time. Okay? So we're going to do one more. We're going to use that formula. Tomorrow we'll do all the other stuff and this. By the time you do something like that, you're just worn out. So this is a tripped out formula that lets you do stuff that otherwise you just couldn't do. Okay? Here we go. Erase. Problem numero 2. Okay, you go. Login number 2 right here. Okay. Doing good. Formula is not going to change on you. Okay, problem number 2, 2x squared. There we go. So we got 2x squared minus x equals 7. Now if you jump in too early, you're going to get all messed up. So once again, what you want to make sure and pay attention is everything on one side, and the answer to that is simply no. So I got to move that 7 so that it's over on this side with these guys. So my 2x squared did not move. Minus x minus 7, you can't combine those because they're not like terms, now equals 0. Now I'm good to go. So let's pull our values off. Number multiplying times the x squared is 2. That's our a value. B, remember there's a hidden number there you don't see, an invisible 1, but it's negative 1. That's crucial. And then C is negative 7. So there's our values of the variable, of the A, B, and C to use in the formula, and we're good to go. Okay, so to give myself a little more room, I think what I'm going to do, I'm going to double check to check. Negative 1, negative 1. Negative 7, negative 7. So I'm going to erase this. Okay, and I'm going to go right into the magical formula. X equals. So this is crucial here. Negative b. So there's the negative sign from the formula, and then b itself is negative. So negative b plus or minus the square root of b squared minus 4 times a times c. A is 2. B is negative 7. And don't forget that whole thing is over 2a. So at this point, you have to check that you put everything else right, or you're just asking for trouble. So you need to make sure you got, let's see, negative b. So I got a double negative. Got it. B squared, not c squared, not a squared, minus 4, that never changes, 2, that's your a, negative 7, that's your c. So it checks. And then down here, 2a, 2a. A lot of people write 2b for some reason. So let's see what we got. X equals, opposite of a negative is positive. 1 plus or minus the square root. Negative 1 squared is 1. Negative 1 times negative 1 is positive 1. Minus 4 times 2 is 8. Times negative 7 is negative 56. Okay? And that whole thing over 4. Okay, is it worth checking that I did it right? You dang right. So the double negative turned positive. Anytime you square a number, you come out with a positive thing. Because even a negative times a negative is a positive. Minus 4. So 4 times 2 is 8. Times 7 is 56. But that's negative 56. So that's minus from here. Negative 56 from there. Okay. So that equals 1 plus or minus the square root. Okay. Same thing that happened to us last time. Leave, change, opposite. So that's the square root of 57 over 4. Now, this is when the quadratic formula gets trippy, because you don't know what the square root of 57 is. So 64 and 49. 57 is in here somewhere. So it's between 7 and 8. So 57 is 8 away from this, and it's, what, 7, it's almost right in the middle. So whether it's 100% accurate, you could use 4.5 or 4.6. So 57, count down, it gets 8 to get here, count up, it gets 7 to get there. So just to be, let's use 4.6. Okay. So what this equals is, okay, x equals 1 plus or minus 4.6 over 4. So you can kind of tell this is going to be harder to do the arithmetic on, so you not to freak out. So what this means is you have x equals 1 plus 4.6 over 4, and x equals 1 minus 4.6 over 4. So 1 plus 4.6, don't forget that's the same thing as 1.0 and 4.6, so that's 5.6. If you found yourself putting 4.7, fix it. So x equals 5.6 over 4. So when you're evaluating that, think of money. $5.60 compared to $4. It's $1.60 over, right? So you got all of 4, and then what you have is you have 1.6 over 4. So half of 4 is 2, so that would be the 0.5 thing. 1.6 is less than 2, so maybe, 0.3. So what I'm driving at is, if you do this, you can just kind of estimate going like this. Goes in one time, subtract, look at that, 0.4, 1.4. So that's one of our x-intercepts. It's about 1.4. We're not sure, it's not exactly, these should be wavy things, because the square root of 57 is not 4.6, it's something close to it. So these are approximations, but that's where one of our x-intercepts would be. Okay. Over here, x equals negative 3.6 over 4. Okay. If you evaluate that in the same way, it won't go into 3, it'll go, so it's 0.9, but it's negative. So the other x-intercept is approximately negative 0.9. So those are your two answers. So as crazy as this is, that is exactly what's going on here. Okay, so when you're finding the x-intercepts, you just have to estimate. So this one, basically, let me show you what I mean by that. Let's say we were here. So 1.4 is going to be somewhere around there. If this is 1 and this is 2, 1.4 will be like there. This is negative 1, this is negative 2. Negative 0.9 would be right around there. So these two things would be our x-intercepts. When we have blow up the graph a little bit, I'll show you how to do that again tomorrow. So crazy formula, absolutely insane to use, but if you're careful, it was good. I made a couple of stumbles early and caught myself. It shows you the value of that, so you don't waste your time. We're going to use the quadratic formula to graph and solve equations the next 2 days. So there you go. We'll also give you a heads up on the harmonicas. Every harmonica has a key printed on it. So see that key of C, that C happens to be the 4 chord of the G progression, and this was a blues in G. So for this particular song we played at the start, we need this specific harmonica to make it sound right. Okay? All right. Thanks for putting up with everything. If you learn something, if you learn we're all human, we all take care of each other. Okay, looking forward to the next couple of days. We'll do more work with this. Keep on keeping on, stay safe, and we'll look for you next time. Okay, aloha.